I'm Greg Pollock, and you're watching Rails for Zombies, Episode 2.
Down your brains and your entrails. It's time to stop and learn some Rails, 'cause we got something new to grab. Rails for Zombies by Andy Labs.
In Episode 2, we're going to be looking at, of course, models. So, in the previous chapter, we had this bit of code, tweet find 3, and somehow that mapped down here to this database table. But there's obviously something missing in between these two pieces of code that map one to the other. And that's where models come in. In this case, we have a tweet model, which is just a plain old Ruby class. So what's happening here, when we call that capital tweet, that's going to be looking at this tweet class. This inherits from Active Record base. Basically, that maps the class to the table. So it's going to go look in the database by default for a plural tweets table, just like that. Let's take a closer look of what's going on when we execute that find code. So when we call tweet find 3, tweet in this case is a class. We're calling a method find 3 on the class, which goes to the database, finds the row that has the tweet with ID of 3. It then populates an instance of this tweet, puts that data into an object, and then stores that in the t variable. Now you may have noticed with Lab 1 that it was possible to create a zombie with no data in it. And in this case here, we can create a tweet with no data in it, which isn't so good. We obviously need some way to validate our model. We can do that in Rails by adding some bit of code. Here in our tweet class, we can add validates presence of status to ensure that a status is put into the model before it gets saved. If we were to test out this new class, if we did t equals tweet.new, we would get back a new tweet object. It hasn't been saved yet. We'll call t.save on it. It's going to return false because it was unable to save it to the database because that validation did not pass. If we call t.errors, we can get back a hash of the errors that came back. And if we call t.errors status for that particular key, we can get back just that particular error. Rails by default comes with a ton of validations that you can use, from numericality to validating uniqueness, confirmation, acceptance, length of, format, etc., etc. With Rails 3, we now have a new syntax for doing validations. Instead of doing them one line at a time, we can say validates status, presence, true. So here you have the attribute and the validation. We can also say validate status length minimum 3. But of course, to simplify all of this, we can write both of these on a single line. Here are the other validations you saw previously, but showing how you might use them with this new syntax. Now it's time to talk a little bit about relationships, because they always travel in packs, and because, you need to have multiple tables and they have relationships with each other. So, as you saw with our previous example, you might have noticed that the zombie Ash had 2 different tweets and we were listing his name twice. That's obviously not very efficient. What we're going to do here is break that out into a separate zombies table. But now we obviously need a way to map which zombies tweeted what. The Rails way of making the association is to add a zombie_ID column to the tweets table. We then specify the ID of the zombie that made the tweet, and we can then map the tweet to the zombie. So now if we add a tweet, one that maybe says your eyelids taste like bacon, we can specify which zombie that belongs to. So looking at this database table, we might say a tweet belongs to a zombie. Inside of our model, to map that correctly, we simply add belongs to zombie. It's important to notice here that we're using zombie singular. We say belongs to zombie because one tweet belongs to one zombie. So now we've mapped the relationship in one direction. How do we map it in the other direction and basically say a zombie has many tweets? Well, if you take a look in the model here, to map that, we simply write has many tweets. So now that we have the mapping correct for each of these models, let's start playing with them on the console. So we're going to fetch a zombie. Then to create a tweet for that zombie, we're going to call tweet.create, send in a status, and specify the zombie. You'll notice in this second line, the tweet gets saved and gets stored in the t variable. We can then call t.zombie to get back the zombie object for that tweet, and call t.zombie.name to print out the zombie that made that tweet, in this case Bob. To explore the other side of the relationship, we can go and get a specific zombie. We can count the number of tweets on that zombie, and if we just call ash.tweets, we get back an array with all of the tweets that zombie has done. Now it's time to get back into the code with Zombie Lab number 2.